Hello everyone, I am Ms. Megha Karwal, Department of Civil Engineering from Praveen Patel College of Diploma Engineering and Technology, Bangalore. In today's lecture, we studied about bridge component parts, remaining bridge component parts. So let's start with the approaches. The length of the communication route affected by the layout and design of the bridge at both of the ends is known as approaches. The portion of the road constructed to reach the bridge from their general route or height are known as a approach. The approaches are constructed in the embankment for high level bridge and culverts while they are provided in the cutting for submersible bridge or causeway. As per the IRC, 15-meter length on the either side of the bridge should be kept straight. The main function of the approaches is to carry the communication route to the level of the bridge floor. Types of approaches: the approaches with the abutment and retaining wall, and approaches running over extended portion of the main bridge. So first is approaches with abutment and retaining wall. These approaches are suitable in urban areas where land is costly. For providing these approaches, retaining walls are constructed on either side of formation of the width of road and the earth filled in between the retaining wall. Approaches running over the extended portion of the main bridge. When the bridge is extended into the bank of river bank for some distance to provide better substructure to the approaches. The extended portion may or may not have the same type of superstructure as the bridge proper. These are the images of types of approach. Bearing. The device fixed on abutment and piers to allow the expansion and contraction and deflection of the bridge superstructure are known as a bridge bearing. Expansion or contraction, movements and deflection which is occurs due to the movement of traffic on the bridge or wind loads when acts on the superstructure of the bridge are transferred out to the piers through the bearings which allow such movements quickly and safely. Functions of bearing: to distribute the load received through the end of the bridge girder over a large area on the top, top of abutment or piers, to allow the girders to move freely along the axis when the loaded, and also to take angular movement at support, to allow the free movement of the girder in the case variation in the length is caused due to change in surrounding temperature, to allow the vertical movement due to the sinking of any supports. Type of bridge bearing: for steel bridges, fixed bearing and expansion bearing. Fixed bearing: the bearing which do not allow any longitudinal movement of the bridge girder are known as a fixed bearing. These are further classified into the following types: shallow or fixed plate bearing, deep base bearing, rocker bearing and knuckle bearing. Shallow or fixed plate bearing. This is the simplest type of fixed bearing. It consists of the flat rectangular steel plate attached to the underside of the lower flange of the girder, and this type of a bearing is suitable for a span of bridge 12 meter. Deep base bearing. This is improved form of a shallow or fixed plate bearing. In this bearing, instead of simple bearing plate, a deep cast base is attached to the underside of the bridge girder. This type of a bridge bearing is suitable for 12 to 20 meter span. Rocker bearing. This type of a bearing consists of the top inverted shoe and bottom with the rocker pin provided in between the shoe. This type of a bearing is suitable for long span over 20 meters. Knuckle bearing. In this type of a bridge bearing, the rocker pin is eliminated by casting the top of the bottom shoe in the shape of the hemispheric to function as a rocker pin. This type of a bearing suitable for long span bridge, that is span over the 20 meter. Its remaining construction resembles to that the rocker bearing, and it's fixed to the top of the piers or abutment and to the girder in similar way as described in the case of rocker bearing. Expansion bearing. This is the second type of bearing. The bearing which allows longitudinal movement of the bridge girder are known as expansion or free bearing. In this, one end of the bridge girder is provided with the fixed bearing and the other end with the expansion bearing to allow for expansion and contraction of the girder due to the variation of temperature and to transmit the horizontal forces to the bridge superstructure. First type of the expansion bearing is sliding plate bearing. This is the simplest type of expansion bearing. This type of a bearing consists of a sole plate attached to the undesirable of the bridge girder, which is free to slide over the wall plate anchored to the masonry abutment. This type of a bearing is suitable for 12 to 20 meter. Second type is deep cast base with the curved plate bearing. This type of a bearing consists of the sole plate which is attached to the underside of breech girder. The sole plate is rest on the top of the deep cast base with curved bed plate which is anchored on the top of the abutment. This type of a bearing is suitable for span 12 to 20 meter. Next type is rocker bearing with curved base. This is a type of a rocker bearing, but in this case, the bottom shoe is provided with a curved bottom which offers minimum resistance to the longitudinal movement of the breech girder. This type of a breech bearing is suitable for span 12 to 20 meter. This bearing allow for the deflection and expansion of the breech girder with reduced horizontal forces. Next type is rocker and roller bearing. This type of a bearing consists of a rocker bearing having its bottom shoe resting on a number of steel rollers which in a turn roll on a honeycombed bed plates is anchored to the top of the machinery of abutment. This type of a bearing is suitable for span more than 20 meter. Next type of bearing for concrete bridge. For concrete bridge, also various type of bearing are used. Bearing for slab bridge. This bearing simple consists of several layers of the tar paper placed between the bridge slab and coping slab of the piers or abutment. The layer of the tar paper are provided to prevent the bonding of the concrete. These bearings are suitable for slab bridge of span up to 8 meter. Bearing for slab bridge are further classified into the following two types: free end bearing and fixed end bearing. Free end bearing. This bearing for concrete slab bridge are usually provided for span 8 meter. This bearing provides free expansion of the bridge slab. Second is fixed end bearing. The bearing for slab bridge which do not provide expansion of the bridge slab but permits its rotating movement are known as a fixed end bearing. These bearing for concrete slab bridge are suitable for span more than 8 meter when the rotating movement and supports are considerable. Next type of concrete bearing is bearing for girder bridge. This bearing is usually consist of lead sheet provided in between two mild steel plates. The upper mild steel plates is anchored to the girder at the bottom and the base plate the coping slab of the abutment of pier. Type of bearing for bearing bridge: fixed plate bearing and sliding plate bearing. Fixed plate bearing. These bearing of concrete bridge are so called because they have an arrangement for fixing the girder to the substructure. This bearing do not allow the expansion of the girder. These bearings are suitable for span 8 to 16 meter. Sliding plate bearing. This is the simplest type of a expansion bearing for concrete girder. This bearing consists of sole plate attached to the bottom of the girder, which slides over the another plate anchored to the coping slab of the pavement piers. This bearing is suitable for span varying 8 to 16 meter. Next is bridge flooring. Bridge flooring is one of the component part of the superstructure of the bridge. The flooring is comprised of following four components: floor beams, stringers, main flooring and wearing surface. Floor beams. Usually they are plate girder or roll steel or RCC joint supported by main girders of trusses. They are spanned or placed perpendicular to the main girder or the longitudinal center line of the bridge. In case of the plate girder bridge, the floor beams are connected to the wave of the main girder. Stringers. They are usually timber beams or rolled steel joist supported on the floor beam at right angle to them. They are either placed on the top of the floor beam or connected to the waves of the floor beam with the help of angle cleat. Main flooring. Broadly, bridge flooring may be classified into the two types: open floors and solid floors. Open floors. The bridge floor, which does not cover the total space between the main girders, is known as a open floor. They are usually used for the railway. This type of a floors or open floor consists of the wooden sleeper placed directly over the main girder. In case of the throw or semi-throw blade girders bridge, the rails rest on the sleeper which are connected over the across the longitudinal place I section called as a stringer. The open floors does not need drainage arrangement. Further, they are economical, easy to inspect and maintain. Solid floors. Those bridge floors which are covers the total space between the main girders are known as the solid floors. Solid floors can be classified as follows: wooden floors, RCC slab floor, throws floor, buckle plate floor, steel plate floor, and jack arch floors. Wooden floor. Wooden planks are clamped securely to the stringers to form a floor. The planks are placed side by side, slightly inclined to the axis of the bridge. For drainage purposes, the gap of 6 to 13 mm is left in between the two successive planks. RCC slab floor. The RCC slab floors may be cast in situ or it may be precast RCC slab. In case of the narrow bridges carrying loads, light loads, the slab may be directly placed on the bottom flanges of the main girder. In the case of the heavy loads, if the reduction in the span is desired, the slab may be a cut continuous across the stringer supported over the cross girder. Throw floor. In this type of a solid floor, steel throw are used for constructing the floor. The throw are placed in the transverse direction to the span across the main girders or in the longitudinal direction to the span across the cross girder. The throw may be filled with the concrete and proper wearing course is provided in the case of the highway bridge. Buckle plate floor. The buckle plates are connected to the main girders directly or with a cross girder in between. The plates are usually filled with the concrete having minimum depth is 76 mm above their tops. Steel plate floors. In this type of solid floors, steel plates about 16 mm thick are used for constructing the floors. The steel plates are connected to the bottom flange of the girder with stringers and cross girders in between the main girders. Jack arch floors. In this type of a solid bridge floors, jack arch are provided or constructed the floor. After constructing the jack arch on stringers, concrete is filled a suitable thickness and a proper wearing surface course is provided in the case of the highway bridge. Wearing surface. The wheel of the vehicles contact with the wearing surface. The main functions are to provide a smooth riding surface to the floors to resist the pressure on to resist the pressure exerted by the traffic and safeguard the slab from the damage to prevent the penetration of surface water into the bed of the load. Thank you.